Hey guys, welcome to week 2 of Unit 9, Linear and Nonlinear Functions. So last week we did rate of change, and you had a homework assignment, and then you had an assessment due that following Sunday. The same will be true for this week. You'll have a homework assignment due Thursday, and then by the following Sunday you'll have an assessment due. What we're going to do today is focusing on identifying functions from equations. We're going to focus on linear functions and absolute value functions today, and then go through the other ones the rest of the week. So let's first start about linear. So linear is what we talked about last semester for the whole semester. We know 3 ways to write a linear equation. It's y equals mx plus b, that's slope-intercept form, ax plus by equals c, that's standard form, and then y minus y1 equals m. X minus x1 is point slope form. So those are the 3 ways we're used to seeing linear equations, linear functions. So when we're identifying them, and if we see one written in that way, right away we know it's linear. But there could be some equation that looks similar to that. How do we know if they're for sure linear? So the best way to determine if something is linear or not, the highest exponent is 1. And the highest exponent is called the degree. So highest exponent, okay? And exponent is that little number we talked about in exponents in Unit 7b. So the highest exponent, and agree, mathematically you're going to see that called degree, okay? The highest exponent equals 1. So when you look at an equation and the highest exponent there is 1, right away there's no 2, there's no 3, there's no variable. Right away you know it's linear. And then also if it's in any of these 3 forms. Okay? And then the second function we're going to talk about today is going to be absolute values. You talk a little bit about absolute values first semester. You talk a lot about them in middle school. Absolute value signs look like this, okay? And in order to be an absolute value equations, it must have these. Must have the absolute value signs, okay? Must have the absolute value signs. So what does the absolute value signs mean? Well, absolute value means how far away something is from 0. So distance from 0. And when we're talking about driving a car, I don't say I drive 2 miles down the road to Starbucks and then negative 2 miles home. We don't say negative when we talk about distance. I drive 2 miles to Starbucks and then I drive 2 miles back. So if I have the absolute value of negative 3, that's going to be 3. And if I have the absolute value of 3, that's also going to be 3. So absolute value, the answer that comes out of the absolute value bars will never be negative. Okay? That's the easiest way to kind of see it. So let's look at these bottom 9 equations, and let's first identify them if we think they're linear or absolute value. And if we're not sure, there might be something else, those are probably functions we're talking about later in the week. So number 1, the highest exponent's 3. Nope. Number 2, the highest exponent's a variable. Nope. Number 3, oh, there's those absolute value bars. So number 3 is going to be absolute value. I'm going to abbreviate that ABV. Okay. Number 4, remember there's no exponent on a variable, there's an imaginary 1 there. So the highest exponent or the degree of number 4 is 1, so this is going to be linear. So right now the only equations we know anything about are 3 and 4. The other ones we're not so sure. Number 5, the degree is 2. Number 6, the degree is 2. Number 7 looks really weird to me. I don't know what that is yet. Number 8, there has an exponent variable. And then number 9, I look down there and be like, oh, the highest exponent on each one of those is 1. So number 9 is also going to be linear. So if you're looking at the worksheet right now, what I would suggest you do on the homework is just go through and say this one's absolute value, this one's linear. Anything you're not sure about, hold off, and I'm sure videos will be coming for those. Okay, so that's how we identify. And then they're going to say this little part right here says f of negative 3. So what does that mean? Well, they want you to evaluate the function when f of x equals negative 3. So what they're saying is in place of, let me make this a little bigger. So they're saying if we look at this equation right here, they're saying they want you to take this negative 3 and plug it in for x, which means I also take that negative 3 and plug it in for x. So I end up with f of negative 3 equals negative absolute value of 7 times negative 3. Okay. The left side of the equation here, I do not touch. I leave it 100% alone 100% of the time. Okay? So I end up with f of negative 3 equals negative absolute value of negative 21. Well, we talked about earlier that an absolute value cannot be negative. So the absolute value of negative 21 is 21, but then you multiply it by a negative and you get 21. So f of negative 3 equals negative 21. So really all that's telling you is you take that number next to the f, plug it into the x in both equations, and solve it. So let's do the same thing here on number 4. They're saying f is 7, so I'm going to take this 7 and now plug it in for x. So I'm left with f of 7 equals 1/7 times 7 minus 5. Well, 1/7 times 7 is 1, so 1 minus 5, so f of 7 equals negative 4, and I'm done. So again, that's when they want you to evaluate. All you're going to do is just plug it in and simplify it down. Again, you do not mess with the left side of the equation. You leave it completely alone. Okay? Let's do one more, and then I want you to make sure on the homework you're evaluating and you're identifying linear and absolute values, and don't go any further than that today. Okay? So on this one, there's f of 4, so I'm going to plug it in for every x. So I end up with f of 4 equals 7 times 4 minus 10 times 4. Now there's a couple different ways to do this problem. Obviously, you could do 7x minus 10x first, but either way, doesn't matter, you'll get the same answer at the end. So f of 4 equals 28 minus 40. Okay, because 7 times 4 is 28, and 10 times 4 is 40. So then I get f of 4 equals, and I end up with 12. Okay? So that's your lesson for today, identifying linear and absolute value equations and then evaluating those functions. If you have any questions, log on to Zoom. I look forward to hearing from you guys. Have a great day.